Okay. So hello guys, my name is Mohammad Izhaan Khan. And currently I'm pursuing my bachelor's degree in civil and environmental engineering from IIT Patna. So I've got some questions that need to be solved in today's session. Okay. So I should start now. So the first question for the day is the derivation of the double angle formula sine 2x. So as we all know, sine 2x is equals to 2 sine x cos x. So in order to derive this, we can just break these 2x into simpler parts and then cos x sin x. So what have we done over here is simply applied the formula of sin a plus b, right? So sin a plus b is equals to sin a cos b and plus cos a sin b, right? So instead of a and b, we will just simply put x, and by this method, we will generate the formula sin, which is 2x is equals to 2 times sin x cos x. All right. Next up is sin 3x. So note this down first and then I'll move forward. Okay. So next up is sin 3x, which is equals to what? 3 sin x minus 4 sin cube x. All right. In order to derive this, first of all, we must understand the formula for sin 2x is 2 sin x cos x, and the formula for cos 2x is equals to 1 minus 2 sine square x. So we can write sine 3x as sine 2x plus x. So this can be written as sine 2x cos x plus cos 2x sine x. All right. Now this sine 2x can be written as 2 sine x cos x, and further we have in multiplication another cos x, plus this cos 2x can be written as 1 minus 2 sine square x, and there is a sine x in multiplication as well. So 2 sine x cos square x plus 1 minus 2 sine square x can be written as sine x minus 2 sine cube x. Now if I take 2 sine x common, I will be left with 1 minus sine square x plus sine x minus 2 sine cube x. Two sine x minus 2 sine cube x plus sine x minus 2 sine cube x. All right. This will lead to 3 sine x, sorry, 3 sine x minus 4 sine cube x. Now, moving on to the next question. We have to prove that tan of 3x is equals to 3 tan x minus tan cube x whole divided by 1 minus 3 times tan square x. All right. So the similar method will be followed over here also. And tan a plus b is tan a plus tan b whole divided by 1 minus tan a tan b. Take. Then again tan 2x will follow the same method. 2 tan x upon 1 minus tan square x plus tan x and whole divided by 1 minus 2 tan x upon 1 minus tan square x multiplied with the tan x. So we will be left with what? 2 tan x plus tan x 1 minus tan square x whole divided by 1 minus tan square x minus 2 tan square x. So 2 tan x plus tan x will be 3 tan x minus tan cube x 1 minus 3 tan square x. Alright. Moving on to the next question, we will be having sine 3x. Okay. So sine 3x. So how to do for this one? It will be sine 2x plus x, which can be written as sine 2x cos x plus cos 2x sine x. Now we will open the double angle for this sine and this cos. Alright, so this sine will give us 2 sine x cos x multiplied with the cos x plus this cos to theta. Now we will write it as cos square theta minus sine square theta. Cos square x minus sine square x times sine x. Alright, so it will be 2 sine x cos square x plus cos square x sine x minus sine cube x. 3 sine x cos cube x minus sine cube x. So sine 3x is equals to 3 sine x cos cube x minus sine cube x. Alright. Now we will derive cos 2x in terms of tan x. So we already know cos 2x is equals to cos square x minus sine square x. Alright. And cos square x minus sine square x divided by 1. We can write it as this. Now cos square x minus sine square x whole divided by a cos square x plus sine square x. Simple till here. If we divide this whole term by a cos square x, then we will be left with 1 minus sine square x divided by cos square x whole divided by 1 plus sine square x divided by a cos square x. Okay, so I can simply write this as 1 minus tan square x divided by 1 plus tan square x. Similarly, now we will write sine 2x in terms of tan x. Alright. So sine 2x is equals to 2 sine x cos x. 2 sine x cos x whole divided by a 1. This will lead to 2 sine x cos x upon sine square x plus a cos square x. Alright. Now, what we will do is we will divide this whole term with a cos square x. So 2 sine x divided by a cos x, because cos square x, if divided, if we'll be dividing this whole term, then this cos x will be cancelled out. And in the denominator, I'll be left out with a tan square x plus 1. So I'm getting 2 tan x upon tan square x plus 1. Alright, so you can just note this down. Alright, so next up is if a is equals to 3 plus 2 under root 2, then we have to find the value for a square plus 1 upon a square and a cube plus 1 upon a cube. Alright, so if a plus 1 upon a ka whole square we need to write, then we can write it as this. So, and similarly for a cube plus 1 upon a cube, a plus 1 upon a ka whole cube will be equal to a cube plus 1 upon a cube plus 3 times a into 1 upon a into a plus 1 upon a. Okay. So, we must find the value of a plus 1 upon a first. Now, if I need to write a plus 1 upon, I will rationalize this whole term by multiplying and dividing with its conjugate. So 3 plus 2 under root 2 plus, it will be 3 minus 2 under root 2, a square minus b square, 9 minus 4 to 8. So this whole term will get me 3 plus 2 under root 2 plus 3 minus 2 under root 2. So it will be a 6. Now a plus 1 upon a is equals to 6. This we know. What did we need to find? We were asked for a square plus 1 upon a square, which is equals to a plus 1 upon a ka whole square minus 2. This whole term is a 6 ka square minus 2 is equals to 36 minus 2 is a 34. Similarly, for a cube plus 1 upon a cube will be a plus 1 upon a ka whole cube minus 3 times a plus 1 upon a. So 6 ka cube minus 3 times 6. So 6 ka cubes, 36 into 6 is 216 minus 18, which will be equal to 198. Alright, so this is how we can do these kind of questions. Alright, so the next question that we have is of AP. So we have to find the 31st term of an AP, which will be what? If A is the first term, A plus 30 times D. Alright, we have to find this. And further information that has been given to us is whose 11th term is T11 is equals to 38, and 16th term is 73. All right. So a plus 10d is equals to 38, and a plus 15d is equals to 73. And so d will be 7. All right. And since d is 7, a will be a plus 70 is equals to 32 minus. All right. So in order to find the 31st term, I will put minus 32 plus 30 times 7, which will be equal to minus 32 plus 210. So it will be 178. This will be the solution for this question. All right. So moving forward, next question is derive S is equals to ut plus half a t square, where S is the distance covered in meters. U is the initial velocity in meters per second. T is the time in seconds. A is the acceleration in meter per second square. Moving onwards to the solution. Now we will let the initial velocity be u and the final velocity be v. All right. So the average velocity of the body will be u plus v by 2. All right. So if the body takes t seconds to travel a distance of s, then the distance s that will be covered will be the product of average velocity multiplied with the time taken. All right. If we put v is equals to u plus at in this equation, we will get s is equals to u plus at whole divided by 2 times t is equals to 2u plus at divided by 2t. Now it is nothing but ut plus half a t square. There is a graphical method as well for this same derivation. Now, if I draw the velocity time graph, if I draw and if I say that the initial velocity is u, and the final velocity that it is reaching is, let's say, v. All right. So this is a straight line. I'll try to draw it a little more neat. And the time taken is t. Okay. Now the distance s will be the area of vt graph. Now what is the area? Area will be the area of the triangle, है ना? So s will be is equals to ut, which is this rectangle, plus area of this triangle will be half into base is t, into height. Height is how much? V minus u. Alright. Now upon solving this, we will get ut half t, and v minus u we can write it as at. Alright. So my s will be equal to ut plus half a t square. Alright. Alright. So the next question up is we have to understand the arithmetic progression. So basically, the basic definition of an AP is it is a sequence in which the difference between two consecutive terms is always a constant. All right. So let's say that I have terms A1, A2, A3, A4, then let's say AN. Now, if you choose any two consecutive terms, these two or these two, if you try to find out the difference between them, A3 minus A2 will always be equal to the difference between any two consecutive terms. So it will be A4 minus A3. Alright. So this is the basic definition of an AP. So if such is the case, then we can say that if our first term is A, let's say that the first term of the sequence is A. So the first term is A. What will be the next term? A plus the difference D. Okay. And in the next term, the same difference D will be added again, 2D, and A plus 3D, and so on. This will be the sequence, right? If the difference between any two consecutive terms has to be a constant, then this is the only way that the sequence can be arranged. All right, where A will always, like we have a basic understanding that A will be our first term and D will be the difference between any two consecutive terms difference. All right, so this is the basic understanding that we have. Now we can generate a basic formula for the nth term of an AP. Nth term of an AP. This is my AP. I'm writing it as such. A3, A4 till A N. Alright. Now, if the AP is defined, the first term is A, then the next term is A plus 1D. Again, a D will be added, so it will be A plus 2D. Again, a D will be added, so it will be A plus 3D. And finally, it will be A plus N minus 1 times D. So, a basic term of an AP, AN, can be written as A plus N minus 1 times D. Now, moving on to the sum of an AP. Now, we have to consider an AP of n terms. Alright. So the AP can be written as A plus D, A plus 2D till A plus N minus 1 times D. Alright. Now, if we, in order to find the sum, if we write these terms in the reverse order, A plus N minus 1D plus A plus N minus 2D plus A plus N minus 3D and so on. And adding, actually, let's just write it as this, and this is my Sn. And if I add these two combinations together, so I will get a 2Sn is equals to what? 2A plus n minus 1D plus 2A plus n minus 1D plus 2A plus n minus 1D and so on. Now I can write that 2Sn is equals to n times 2A plus n minus 1D. So I can write my Sn as n by 2, 2A plus n minus 1D. This is one way to write it, and another way is n by 2, A plus n minus 1D. Now this, what does this mean? This means the last term of the AP n by 2 of the first term plus last term will be the sum of the APSN. So the next question that we have is, if, excuse me, if fx is derivative of gx, then antiderivative of fx is sorry, this is not the question. The question is if an antiderivative of fx is e raised to the power x and that of gx is cos of x, then integration of fx cos x dx plus integration of gx e raised to the power x dx is equals to what? So, as it has been stated in the question itself, integration of fx dx is equals to ex. Therefore, fx will be equal to ex. Alright, and integration of gx dx is equals to x. So gx will be equal to minus of sine x. Now, what do we have to do? The question asked us to find integration of ex cos x dx plus integration of ex minus sine x times dx. So ex cos x minus sine x dx. Now the solution for this whole term we already know. It will be ex cos x plus c. Alright. So this will be the solution for this question. Next up is we have to know about the continuity of a function. Continuity of a function. So basically, what is a continuous function? A continuous function must not, in a layman language, a continuous function graph will look as such. If this is fx and it is changing with x, then there will be no kink and no break in the graph. And like it will not be possible for you to draw the graph of all the functions. So in the mathematical terms, what does it mean to not have any break or any kink in the graph? Is the graph smooth or not? So if you take this point, let's say that this point is A. And if you try to approach this point from the left hand side, okay, and if you try to approach this point from the right hand side, you must come at the same point. So in order to write this, if we are moving from the left hand side, we will say that we are approaching A negative and A positive. If these both are equal, then we will say that the graph is continuous. It is not having any break in it. And in order to show a graph which is not continuous, the graph will look as when you are approaching from the left hand side, you reach this point. And when you are approaching from the right hand side, you reached this point. So the left hand limit is unequal to the right hand limit. This means that your FA negative is unequal to your FA positive. So this is the basic idea of the continuity of a function. Next up, the question that we have is the adjoint of a matrix. Adjoint of a matrix. So if A is equals to, I'll draw a 3 cross 3 matrix. A11, A12, A13, A21, A22, A23, 31, 32, and 33. And I'll write the determinant of this matrix as the determinant of this A11, 12. Now, the matrix formed by the cofactors of the elements. It will be nothing but A11, A12, A13, A21, A22, A23, A31, A32, and A33. Alright. Now, in order to write these A11, A12, I can write the cofactor as such: minus 1 raised to the power of 1 plus 1, and determinant of A22, A33, A23, and A32, A33. So it will be A22, A33 minus A23 times A32. Alright. Next up is A12 minus 1 plus 2. So A21, A23, A31, A3. It will be a minus A21, A33 plus A23 times A31. Now A13 will be minus 1 plus 3. A31 and A32. I can write this as A21, A32 minus A22, A31. Now, next up is A21 minus 1 times 1 plus 2, A12, A13, A32, and A33. This can be written as minus A12, A33 plus A13 and A32. Next up, we'll do the same thing for A22. Since the summation is even, I'll ignore the minus 1 part, and it will be A11, A13, A31, and A33. So it will leave me with A11, A32, A33 minus A13, A31. Alright. Now A23 minus 1 times, what is this? A23. So it will be A11, A12, A31, A32. Alright. I'll be left up with a minus A11, A32 plus A12, A31. And similarly, A31 will be A12, A13, A22, and A23. So it will be A12, A23 minus A13, A22. A32 will be a minus 1 times A11, A13, A3. It will be a minus A11, A23 plus A13, A21, A32. Since the summation is even, A11, A12, A21, A22. So it will be A11, A22 minus A12, A21. Alright. Now, basically, what is the adjoint of a matrix? Adjoint of a matrix is the transpose of the matrix of cofactors. Transpose of the matrix of cofactors. So, in order to write this, I can simply write it as A dot adjoint of A is equals to determinant of A times identity matrix. So in order to prove this, we can simply do, we have capital A times adjoint A11, A12, A13. Only if we write it all down, we will be left with just simply determinant A 0, 0, 0 determinant A 0 and 0, 0 determinant of A. If we take the determinant of A common, I will be left with an identity matrix as such. So this proves that A adjoint A is determinant of A multiplied with an identity matrix. Let's so moving forward, we have the addition, subtraction, and multiplication of a complex number. So basically, a complex number is a summation of real and imaginary number. If the first part is addition, I'll just C1 plus C2. So it will be A1 plus iota times B1 plus A2 plus iota times B2, and addition slash subtraction. So it will be A1 plus minus A2 plus iota times b1 plus minus b2. Alright, so this is the basic concept for addition, subtraction. For multiplication, a1 plus iota times b1 multiplied with a2 plus iota times b2. So it will be a1 a2 plus iota times b1 a2 plus iota times a1 b2 plus iota ka square is minus 1 times b1 b2. So we are getting a1 a2 minus b1 b2 plus iota times a1 b2 plus a2 b1. So the next question that we have is integration of 1 minus sine 2x. So I can write it as sine 1 can be written as sine square x plus cos square x minus 2 times sine x cos x. Alright. Now I can write this whole term as sine x minus cos x the whole square. Now, if I take cos square x common from this whole thing, then I'll be left out with 1 upon cos square x dx upon tan x minus 1 plus whole square. Now, this will be what? It will be an integration of sec square x upon tan x minus 1 का whole square dx. Now, if I put tan x minus 1 as a, then dA will be sec square x dx. So it will be integration dA upon a square. So it will be minus 1 upon a plus c. Alright. Now it will be minus 1 upon tan x minus 1 plus c. So 1 upon 1 minus tan x plus c. This will be the solution. Now next up is the last question for today, and the question asks us to factorize x square plus 10x plus 24. So I can write it as 6x plus 4x plus 24 x plus 6 plus. So this will be the factorization of the above term. So this is all for today, and this is where we will be ending our session. Thank you for joining.